Hello everyone. First of all, I would like to welcome all of you to our online EE306 lab series. The main topics of this lab are the magnetic circuits, transformers, generators, and motors. However, in the first two experiments, we will be reviewing our previous knowledge on electrical circuits as well as we will be going through the introduction of CASSY software. Now let us have a tour to our EE306 lab. Hello guys, this is the Electromechanical Devices Laboratory in the Electrical Engineering Department at King Fahd University of Petroleum and Minerals. In this lab, we have a total of 5 workstations, and as you can see that each of the workstation is equipped with various kind of components. Now let us see what are the major components we have in this lab. This is the workstation. At the bottom of the workstation we have the power supply, and at the top of the workstation we have other electrical components. As you can see in the right side we have the computer for data recording. This is our main power supply in the workstation. And this is the equipment power supply. We have resistor bank, capacitor bank, inductor bank, field rheostat, magnetic circuit, single phase transformer, AC/DC machine and their control unit. Also we have safety fuses to isolate the equipment in case of emergency. For data measurement purposes we have multimeter, isolation amplifier, profi and sensor CASSY. Using the profi and sensor cases we can measure only the voltage quantities in the range of plus minus 10 volts. But in reality, we have to measure the current quantities as well as some quantities greater than plus minus 10 volts. In this regard, the isolation amplifier converts any signal into voltage signals, and also with the help of this control knob, it scales down any signal into plus minus 10 volts. Finally, we have the connecting wires to prepare the experimental setup by connecting the components, as well as we have the computer unit for data recording. Now let us see a typical experimental setup where we have the main power supply, we have the data acquisition system, we have experimental components as well as we have a computer with CASSY software. After making the connection, we turn on the main power supply to energize the data acquisition system, then we do the CASSY settings in the computer. Finally, we turn on the equipment power supply which is connected to the experimental components through the safety fuses. During our experimentation, the data flows from the experimental components to the data acquisition system, then to the computer system for recording. The name of our first experiment is Introduction to CASSY Lab. In this experiment, we have 3 objectives. Our first objective is to learn and experiment the measurements of electrical variables through the digital data acquisition system in connection with CASSY Lab computer interface. Our second objective is to measure, display and record DC/AC quantities, then extract subsequent quantities online and offline. Our last objective is to plot and analyze the results. This experiment is divided into 3 parts. In the first part, we do some preliminary measurements. This is our experimental workbench. In this experimental workbench, we have this resistive load. And at the beginning of our experiment number 1, we have to measure the resistance values. So this is how we have connected. As you can see that we have one variable resistor and one fixed resistor. In the multimeter, the value is 1.848 kilo ohm. Using the multimeter, we get these resistance values for the inductor and the resistor banks. Before making an experimental connection, we must have to check the resistance values of the fuses as well. For the healthy fuses, the resistance value should be close to 0. This is our experimental setup for the DC measurements. While doing the CASSY, we must have to select the average values as we are going to measure the DC quantities here. And then we have to select the manual recording as per the guideline of the manual.
This is the workbench. Now you have the power supply here, right? There are 2 AC supply and 2 DC supply, okay, one variable and one fixed. Now today we are going to use in the first experiment DC supply variable. Now if you look here, this is the board and it's written in the manual, you can see 40 to 250. So if there is a range given, that means it is a variable supply. DC will have a positive and a negative, and for AC, you know, it will have line 1 or whatever, phase 1, L1, L2, L3 and neutral. So this is the power supply. Now here is your fuse. you remember this is the simplest of the protective devices, which basically isolates the circuit from the power supply in case of high current. Okay, so that's the function of the fuse. Okay, we always connect our equipment through the fuse. So from the power supply, we always take it to the fuse, though it is not shown in the circuit diagram. Okay, for DC, only the positive will go to the fuse, negative you can directly connect. And for AC, the neutral is not to be connected to the fuse, but if you are using three phase, all the three phases L1, L2, L3 will be connected to the rest of the circuit through the fuse. So that is the fuse. Every component, you remember, has got two ends. So fuse also has got two ends. You can connect it to the either one, okay, input and output. It's not necessarily the input. You can do it here and then you can reverse it. There is no problem. Okay. Now this is the isolation amplifier. Okay, this is the isolation amplifier. It has got 4 channels. That means it can record 4 variables. Okay, there is a channel A, B, C and E. Okay, and each channel will have 3 terminals. Okay, OA, which is generally for neutral. O is for neutral. Okay, and there is an I and there is a U. If we are connecting for the voltage, we will connect to U and O. If we are using current, we will connect to I and O of the same channel. Remember, when you measure the voltage from your 2-level circuit lab, we do it in parallel. When we measure the current, it has to be in series. So this is the isolation amplifier. You see this switch here? Okay, it's a selector switch, 1V over A, 1 by 3VA divided by, this is basically to attenuate the signal. That means we don't want the full voltage to pass through the equipment. We want to bring it down, okay, in case of the voltage. Otherwise, you see the design of these components will be very, very bulky, very large. It will not be as simple as that. Okay, so in case of the voltage, we put this at divided by 100. So you can move this. So divide by 100. You see, we are connecting to the voltage U. Whenever you connect to the U, it means we are measuring voltage from that channel. Measuring 2 variables here, one voltage and one current. These 2 channels will go to the CASSY. Now this is the CASSY, Profi CASSY and the sensor CASSY. Okay, so it has got 4 channels, 2 here and 2 here. Okay, we take it from the input. You see the A and the B. So this is, it's written in the pencil, UA1 and UB1. So the first one from the amplifier, we connect to UA1, second one, we connect to UB1. So UA1 will measure the voltage and UB1 will measure the current. And of course, you have to connect all the grounds together from the amplifier and the CASSY. So this is the ground of the amplifier and here is the CASSY. So that is about the hardware part. Now let's come to the load. Okay, now this part, okay, is purely resistive load. We are using a DC supply, then we want to see the voltage current characteristic of the load. Now this is the load. Okay, line 1, line 2, line 3. We have paralleled it. Let's come to the software part, the data acquisition. How do you acquire these data? You remember, you are not using measuring instruments that you will see and note down the reading. This computer is connected to the hardware, CASSY hardware, and it gets all the data here. So CASSY Lab, when you double click it, you get this program, and this is the first menu. Now you go to change settings. When you put the cursor here, it gives you the definition. Okay, if I go here, okay, you see one is CASSY parameter, then you have modeling, the comment and general. You start with the first one. The first task is to activate the channel. We connected these channels, okay, UA1 and UB1 there. So if you look at this picture here and you look at the picture of the hardware, if you look at the picture of the hardware and you look at this picture, okay, it's similar, right? So here we have connected to input A and B, UA1 and UB1, which is the top 2. So if I click on this black button, it will show UA1, okay, and I show UA1 and becomes red. That means my channel UA1 has been activated. If you do not activate, you cannot get the reading for that channel. Now the same thing I will do it for the other channel. If I'm using 2 channels, I will activate this one. So, okay, UB1 also turn red. So both these channels are activated. Now remember, when you make measurement for the DC, you record the average value, right? When you do it for the AC, it is RMS value. So you have to do this setting. So this is my channel UA1. There is a selection instantaneous average of this thing. So this is DC measurement. So DC voltage average value. Okay. Now we have to put the formula, which is recording what. So I put load voltage and I put the formula. It's given in the manual. UA1 times 100 because you have divided by 100. And you put the units and the range. And then the other variable you are recording is the current, which is UB1. It is 1 VU over A. There is no divided by 100. And we put the symbol on this. Now you want to display. So N, we have VL and IL. These are the three things. Okay, N is the number of readings at different resistance, and we make this. You can always change this. This is for the plotting. Okay, so we have switched on the power supply. You can see here, and we have increased the voltage to make it 100 volt as written in the manual, and you get the current. So now the resistance is at 100%. Okay, so your first value is at 100%. Then we change the resistance, reduce it in steps of 10, and we record the voltage and the current from the manual recording. Either you can click on the clock or there is F9. So you get a series of reading. Okay, 100% all the way to 30%. So this is the voltage and the current profile. Now you see here, this is what you get. X-axis is the number of readings. That means the first reading is at 100%, the last is a 30% resistance. We are not, okay. And then you have the voltage is fairly constant. We are not changing the voltage. So as expected, it should be constant. And the current should increase as the resistance is decreasing. Simple DC circuit measurements. Okay.
This is our experimental setup for ACRL circuit measurements. For this part, while activating CASSY, we must have to select the RMS values. Then we have to do manual and automatic recording as per the manual guideline.
This is the second part of the first experiment, which is for the AC circuit. You see we have RL load that we have connected in parallel. Okay, this is the resistance and the reactance, only one phase. Okay, not the three, we did not parallel it. Okay, rest of the connection is exactly the same as the previous circuit. Now this is the power supply we are going to use, L1, L2, L3, N. We are using only one phase. Okay, so phase 1 and the neutral. Phase 1 will go to the fuse, neutral can connect to the direct. Rest is the same. So we increase the voltage using this switch, okay, as required to 100 volts. So you see 100 volts here. And you see 100 volts here on the, always this is more accurate, we take the reading, but close to 100 volts. So the resistance is at 100% and we take the first reading. Same thing we are going to repeat as we did for the DC circuit, reducing the resistance in steps of 10, and we go up to 190 like that, up to 30, and we record the voltage and the current. See here, there is a power factor, cosine phi, this is AC, okay? So we display this also, and we record this. Okay, the last part of the experiment 1 is to do it for automatic recording. We have done it for manual recording by changing the resistance. So we do all the settings as given in the manual for the automatic recording. Okay, and we have 100 volts here again, and we just press F9 or the clock. Okay, and you see this beautiful curve of the voltage and the current over the whole span of time that you set as in the automatic recording.
From this experiment, now we have 2 manually recorded CASSY files from both DC and AC circuits, and also we have 3 automatically recorded CASSY files from the AC circuit. One of the requirements of our report is to find the power factor. Now think A is our voltage signal and B is our current signal. As you can see, the time shift between the two signals is tau millisecond, as well as they have the same time period, which is capital T millisecond. Now using your knowledge of EE204, you can calculate the phase shift between the two signals. From the phase shift, you can calculate the power factor. That's all.